It's the first mouse that has analog type of technology. Up until today, we didn't really know how gamers were clicking on their mouse.
With the design by collaboration, we realized how successful we were, because some of them switched to our mouse, right, 1 week before a tournament. So it's been for them, it was a seamless adoption.
60 micrometer is the size of a human hair, right? So many people call when you set to highest sensitivity, they call that the hair trigger, because you just have to move by the width of a hair to get the switch to register, right?
I recently sat down with Logitech's chief engineer, Regis Croisonnier, and another engineer called Frédéric to talk about the Logitech G Pro X2 Superstrike, Logitech's new mouse. This mouse allows you to set your actuation point super low and enable rapid trigger for speedier clicks. Logitech calls the technology that underpins this HITS, or the Haptic Inductive Trigger System. As the name suggests, there are two parts to this, induction and haptics. Essentially, pressing your left or right mouse button makes a small piece of metal move through a magnetic field that's generated by a coil, and the sensor can measure this disturbance to the field and tell how far the button's been pressed. When it reaches the point you've set it to, it'll trigger a click, which makes the haptic vibration motor rumble, and this feels like a mouse click. These technologies aren't completely new, but they are new to gaming mice, and they've never been combined in quite this way before. The obvious place to start is with the difference between Logitech's inductive system and the Hall effect that's used in many of the latest analog gaming keyboards.
In keyboard, the big trend right now, it was Hall effect sensor. Now it's also moving to TMR. Both works with a magnet that's on the plunger of the switch of the keyboard. You know, full-size keyboard switches, they are 4 mm of travel, and this technology is actually quite nice to really sense over the full range that we have here. So 4 mm, it's quite a long travel, right? Now we will think about the mouse. Here it's less than 1 mm of travel. The average total travel distance is more like 0.65 millimeter. In that case, inductive sensing is much more sensitive to this type of very small displacements. So it was kind of the obvious choice to integrate this technology in there.
I'd heard from other manufacturers about a lack of accuracy in Hall effect technology due to manufacturing variations, so I was keen to know if the induction technology here helped avoid this.
For this type of variation that we might have in the process, we have dynamic calibration. So we are always adjusting to all the variations. So there's calibration at the production, and then we also dynamically calibrate during the life of the product to account for all of these errors. So it's also working with magnetism, but it's more like magnetic field. It's more of a field. So the coils that you see, you saw the picture where you see the two coils, the pair of coils that are each key plate, they will generate a magnetic field, but a magnetic field that's not static. It will vary. It's very short pulses of magnetic field. And these short pulses of magnetic field will induce some current inside of that metal plate. So the metal plate has to be conductive, and this current in the metal plate will interact with the main magnetic field, and we can measure this interaction and then determine the distance between the coil and the target.
I was also keen to learn about how quickly the induction switches could respond, given the differences between sensor and microcontroller workloads on induction and Hall effect keyboards.
Most of the time, the Hall effect sensor will kind of directly spit out the information. So there is an output on the little chip that you put under the switch, under the magnet, and you just have to read it right away. For inductive sensing, so it's as fast as this, but we had to implement, so it's our own solution that we developed for inductive sensing, and we had to implement the driving ourselves in the microcontroller. So it was a big part of the project also to be able to drive them precisely and to get that output directly from the microcontroller. The time it takes to sample one of the coils that you see here, one of the sensor, is less than 10 microseconds. And at 8 kilohertz, we have availability of time of 125 microseconds. Yeah. So the way we've done it now, less than 10, and both sensors, both keys are being sensed in parallel. So overall, less than 10 microseconds for both of them.
So there are two technologies coming together in the HITS system. That's inductive sensing and haptic feedback. I wondered which one they implemented first in the Superstrike.
This idea of having analog sensing in products is not new, right? We've been doing prototypes a while, and there's analog in keyboards. The analog keyboards, there's no tactility, but it appeared to be fine for the gamers that there's no tactility in the keyboard, because anyway you will bottom out the keycap, right? You will touch the bottom, and basically the tactility kind of come from the impact at the bottom, even though the switch was registered like much earlier, right? On a mouse, it's kind of a very different scenario. You really don't use the mouse the same way you will use a keyboard. You need much more precision on the way you input stuff on the key plates here. And so we had some prototype a while back without any haptic feedback, and we noticed it's not usable as a product, the mouse. The gamers, they need this tactility to give them confidence that they register the click. The function associated to the mouse clicks are so important in game, you cannot not be sure something happened, right? What we saw is that the gamers will often, when they first use the mouse, set it to the strongest setting, so where it vibrates the most, so that they are really sure something happened. But then they realize it's not the most comfortable one, it's not the one that gives you the most performance, so they usually gradually take it down. But it's kind of a pretty fast learning curve to just find the sweet spot and to be sure that you registered your click.
You can disable the haptic, right?
Yeah.
And you quickly understand that, oh my gosh. It was the obvious thing, right? To tell, okay, we need to have a haptic, right? To provide the same click feeling that people have with their regular mouse,
Basically, you tried the induction first, you realized that it didn't feel great without haptics, and then you added the haptic.
I think we knew we would need the haptic anyway. I think it was obvious. Okay, if you take a switch, there is two functions, a sensing and a click feeling, right? We need to rebuild it, but how might we make it customizable? Now the implementation, this is where we had to put a lot of, energy to tune the experience to reach a level where everybody loved it.
We need to have this kind of actuator inside, because with rapid trigger, the click can either occur at the top, at the bottom, or at the middle. You cannot put something static that generates some feeling at the same location, otherwise it will not be in sync with when the click is being sent to the computer, right? And we really worked hard to make sure that as soon as the click is being detected, we can trigger the haptics right away, and you feel it instantly as soon as you send the click. And also on the click that you feel, so this was it took a lot of time for us to really optimize this feeling, because the component we are putting inside, it's more like a buzzer. It's not meant to generate click feeling, it's meant to make long vibration, kind of a razor type of thing. So really had to work out on the driving of this, also working with the supplier of that LRA component to really optimize what we can do with that component, and then we work with the pro to understand what was the feeling that was kind of a legacy type of feeling from the Superlight mouse. So testing with the pro, what's the best sensation to generate with this, and then we landed it on that type of feeling that we provide to 5 different levels of intensity.
And here, I think, with the design by collaboration, we realized how successful we were, because some of them switched to our mouse, right, 1 week before a tournament. So it's been for them, it was a seamless adoption.
So far, there hadn't been any talk about potential downsides, so I asked whether the pro players that Logitech had worked with had asked for anything they struggled to accommodate.
What we learned a lot was on the degree of customizability that they wanted. Because we have this technology that's capable of a lot, and then it was a matter of giving them the range they need for the customization. Don't give too much, do not give enough. So this we really had to work with them to understand what's sensitive. So right now it's divided in 10 steps, the sensor, which we define as the sweet spot for them to have that level of customization, why not be overwhelmed by too many settings. When we are talking these 10 steps, so as we say, we wanted to keep the exact same travel distance as a normal switch, so this 0.65 millimeter. So now we have 10 steps of sensing onto this, meaning you take this 0.65 divided by 10, it's about 60 micrometer of displacement. 60 micrometer is the size of a human hair, right? So many people call when you set to highest sensitivity, they call that the hair trigger, because you just have to move by the width of a hair to get the switch to register, right?
The Superstrike is combining some bleeding edge technologies, so I wondered whether this might give the mouse more points of failure and cause problems long term. For instance, there have been double click issues with some mice in the past.
The double click issue often occur from mechanical issue inside of the switch, right? Because in a normal switch, you will have this this contact, you have mechanical contact, so 2 metal plates that touch together, and you have the electrical circuit that's being shorted, and this will age, and because of that impact, it will just create some erosion, dust, whatever. And this is where most of the issue come from, because of impact. Here, it's really a switchless mouse. There's no switch, there's nothing that impacts. It's with only a key plate moving in the air, and that key plate being able to oscillate, but always suspending in the air. So it's much more likely to fail because of this kind of usual failure point. It's the first mouse that has analog type of technology. Up until today, we didn't really know how gamers were clicking on their mouse. Do they preload a lot the switch? Do they lift the finger? Do they go all the way down? Do they oscillate in the middle? This is all new stuff that we were able to now monitor for real on pro gamers. And really, what we saw is that everybody's different, right? So it's really why it's important to set the settings. If, as you said, the sensor will sense everything that you do. You move by a few tenths of micrometer, sorry, we will record it. So if it happened and that's not what you wanted to do, you want the mouse kind of discard it, then just change slightly the setting to be slightly less sensitive in this area where you don't want to sense. It's new technology that opens up a whole new world of possibilities, but also of issues, but these issues can be solved with the customization.
Technology-wise, there is no mechanical piece in friction. We have more robust system in terms of lifetime, right? And then on the other side, our technology is robust.
Superstrike is about the same weight as the previous Superlight 2, and that's heavier than some other mice on the market these days. Logitech doesn't see this as much of an issue though.
So when we did the really first proof of concept, the traction was immediate from the Pro. So very quickly, we went on the production of prototypes, which were 3D printed and with CNC parts in them. And those, so we gave 150 of these prototypes to the Pro gamers, and those were at 68 grams. So we are a bit concerned if that would be too heavy, but we just wanted to give them very quickly the prototype for them to try the HITS technology. And the feedback we had from this is that the improvement, the benefit from the HITS technology was really the thing they care about, that the weight was kind of secondary for them. But we knew from the beginning that we had to reduce this weight, right? But since it was a very short project and we wanted to announce it in September for the Logiplay event, we were at the pilot build phase. And at this point, we only managed to get the weight down to 64 grams. So at this stage, we announced 65 to be safe. But we had some more months to work on it, and we really shaved down everything we could into the mouse while maintaining its robustness and the Logitech quality, right? And now it's 61 grams.
If you can give numbers, usually when you start to talk about the technology or prototype, right, between the time we have the proto, the time we implement in a product, I would tell average time is between 2 to 3 years. Here, we knew we had a gold nugget in our hands, right? So we wanted to move fast. So we took all shortcuts we could, right? Because why? As Fred said, we did, 3D printing, we found other way to move fast. We are trying to do what makes sense. So we said, okay, lightweight, reach a point where everybody can enjoy it, right? What's next? How can we even further improve the experience and performance of our gamers? We have plenty of other ideas, right, in the pipeline. We're trying to optimize our embedded software to save 10 microsecond latencies, right? Good. But how might we do it differently? And I think Superstrike is a good example where we came with a new technology helping us to save 30 milliseconds. Yeah. So it's much bigger than what we're trying to achieve by saving 10 microseconds here or here,
The Superstrike's new tech is definitely exciting, but it does come at a cost. $180 to be precise. I wanted to know whether this technology could be ported to cheaper mice down the line.
No doubt, one could consider, I think now we need to understand, right, we need to keep working with Pro. I'm sure we learn, we improve, but no doubt at some point, all technology is right. At a certain point, they start with the high end, and slowly but surely you can put the technology, in the other hand, right? Yeah. So I could foresee it could be the same for such type of technology.
Since talking to the two engineers, I've had tons of hands-on time with the Superstrike, and I must say I don't think they were overselling it. The only real question I have now is how long it will take for the technology to spread to the gaming mouse market at large. So what do you think? Will this change the market? Let us know in the comments below.